Dear students, today we are going to study about inverse Laplace transformation by a new method called convolution method. Let us see what is the definition of convolution of functions. If you are having two functions like f of x and g of x, then the convolution is given by f convolution g of t is equal to integral from 0 to t f of x g of t minus x dx. This is the definition of convolution of two functions. Note that whenever we are having t here, the integral limit will be from 0 to t, and we will use a new variable x here. So t minus x will come here and the integrand is dx. So this t will come here and this x here x and dx. Remember this rule. This is the convolution of two functions. Now we are going to see how this convolution will be helpful to find the inverse Laplace transformation. The advantage of using this theorem is inverse Laplace transformation of a function like this a of s multiplied by g of s is given by L inverse of a of s into g of s is equal to L inverse of a of s convolution L inverse of b of s. Note that you have to read this as convolution. So the advantage of this rule is if two functions are there, then independently we can find the inverse transformations and we can do convolutions. Let us see how we can apply this in the problems step by step. Step 1. Suppose if you are having a function f of s which is complicated, you should convert this into two small functions such that each of them have inverse transformations. If f of x is having like this, a complicated function, convert this into two parts a of s, b of s. So make sure that a of s and b of s are simple functions where we can find the inverse transformations. So converting which is a of s and which is b of s is more important. You have to convert in such a way that a of s and b of s, they are having inverse transformations by basic rules. After converting this, just find the inverse transformation. Let us say that inverse transformation of the first part a of s is f of t and the second part b of s is g of t. So a of s inverse transformation is f of t and b of s inverse transformation is g of t. Hereafter we are going to apply the convolution of functions. Literally the inverse transformation is completed. Now we have to complete with the convolution theorem. First step is convert the t into x in the first function, and in the second function convert the t into t minus x. Like this, t should be converted into x and the second function t should be converted into t minus x. So this is the next step. What is the fourth step? Substitute the results of step 1 and step 2 in the convolution functions a for the formula. A formula is given in our previous slide. Now we have to take this f of x and g of t minus x, put it in this, just multiply them. There is no convolution in between, just multiply them. Then we have to find the convolution for these functions. What is the convolution rule? The convolution rule is take this f of x, take this g of t minus x, now introduce the integral from 0 to t and complete this integration with respect to dx. So that gives the final solution for us. Find the inverse Laplace transform of f of s equal to 2s divide s square plus 4 whole square. Very first thing is why we are going to use convolution theorem. Here s square plus 4 whole square, there is no direct rule to find the inverse transformation, But if you're converting it into two small parts, like first we can take 2 divide s square plus 4, and second you can take s divide s square plus 4. This whole square was converted into s square plus 4 multiply s square plus 4, and this 2s, take any one party here, the another party here. Here I have taken 2 here, s here, but if you are taking s here and 2 here, that is also your right choice. The main thing is you have to make sure that this part can be easily Laplace inverse transformed, and this part is also having inverse transformation. So now let us find the inverse transformation for these two functions. Inverse transformation of 2 divide s square plus 4 and inverse transformation of inverse transformation of 2 divide s square plus 4 and inverse transformation of s divide s square plus 4. The basic rules we are applying: 2 divide s square plus 4, the basic rule is sine 2t, and s divide s square plus 4, the basic rule is cos 2t. Remember that in between we are putting convolution symbol. This is not ordinary multiplication, this is convolution. According to this slide, the inverse Laplace transformation is completed. Now in the next slide, we are going to take the first part as f of t and second part of g of t. We are going to find the convolution for it. Here f of t is sine 2t. First step, we have to transfer the t into x. So f of x is equal to sine 2x. Second step is we have to convert g of t into g of t minus x. So we have converted the t into t minus x. Now let us see what is a convolution rule. Convolution rule is f convolution g of t is equal to integral from 0 to t f of x g of t minus x. This is the convolution rule. So we found f of x for this part and g of t minus x for this part. Let us substitute this in the rule. F convolution g of t is equal to, this is the rule, and we have substituted f of x is equal to this and g of t minus x here. Now there is a multiplication of two functions. You know how to convert the multiplication of two functions into addition of two functions. I put a separate video for this. If you don't watch, please go back and watch the video how to convert product into sum. Now we are going to use that rule. So by using that rule, we are having sine 2x plus 2. This is the part A and this is the part B. So A plus B is here plus A minus B is here. Okay. Now let us make the simplification here. So we will take this plus here, plus into plus 2t, plus into minus 2x, and here minus into plus is minus 2t, minus into minus is plus 2x. So this is the simplification. Now there is a possible cancellation here. You can cancel this 2x with this 2x, so we can cancel. So next step is you have sine 2t plus sine 2x plus 4x. We have simplified into 4x now. So this is our previous slide. Now we have to do the integration. We will apply the integration for both the terms. So there is no x here, so I take out of the integration, I just multiply it by dx, and here there is a x, so it is not possible to take out of the integration, so I make it as sine 4x minus 2t dx. Now integration for this dx is simply x, and for the sine term the integration is minus cos 4x minus 2t divide this a. So divide by 4. We have to substitute the limit from 0 to t. Now let us substitute the limit. You know that when you are substituting the limit, we have to substitute for this x First to the upper limit x is equal to t minus, then the lower limit x is equal to 0. Same thing we are applying it here. We applied t to here, 4t minus 2t minus, then put 0 here, so 40 minus 2t. So I have multiplied this 4 with 2, it is coming 8, and this minus with this plus, it's coming minus. So we have substituted the upper limit and lower limit. Very few simplifications are left out. They are, so multiply t with 1, I make it t, and here minus 1 by 8, 4t minus 2t is 2t, and 40 is 0. We are having minus cos minus 2t, and you know that cos of minus 2t will be equal to cos 2t. So in the next step we are applying cos minus 2t becoming cos 2t. Here cos minus x is equal to cos x. There is a rule. Now these two things are same, cos 2t, so they are getting cancelled. The next step, it becomes only this part because this term is coming 0. So this is the inverse Laplace transformation of the given function by using convolution rule. I hope you enjoyed learning mathematics with me. Please subscribe to this channel and click the bell symbol to get quick updates. Take the quiz given in the description. Wish you all the best. See you in the next video. And this is your favorite maths channel, We Learn Math.